Alright, so oops, let's drag all of this out of here and let's get to 100%. Alright, so the next question: what is the area of the shaded region in the given circle in terms of pi and in simplest form? Okay, so let's take a look at the circle right here. So we're going to draw it out. Going to have O, going to some P, some point R, some point Q. I have this line here. I apologize for the bad drawing, but we're going to have an angle here of 60 degrees. And we know that the radius is 6 meters. Okay. So, alright. First thing we notice, correct observation notice in the solution, is that if we have an angle of 60 degrees in any triangle, right here, and two of the sides are equal, so we know that since this is a radius and this is a radius, that means that these two angles must also be equal, right? The only degree amount left to set, so let's assume that the value of this angle is x, the value of this angle is y. We know that x has to be equal to y, and that x plus y have to add up to 120 degrees, because obviously 180 degrees total for the whole triangle. So this implies that if we can substitute x in for y, 2x equal to 120 and x equal to 60 degrees. So that's how we show that this is an equilateral triangle. Now, the way that we actually find the area of the shaded region, it's everything except for this part. So I'm going to shade this part, as I can't really shade the entire thing without ruining the graphic. And I'm going to shade this entire part, and we have to find the rest of it. So if we can find the area of the entire circle and subtract it out from here, then we're fine. So first of all, we're going to find the actual area of this segment, right? So hold on a second. So wait, I'm sorry, what is the area of the shaded region? Okay, yeah, I got that right. I thought we were finding this little part here. So we have to find the actual segment and subtract the majority that's missing, the small piece, from the triangle. So we write the area down here. Basically, it's going to be a fraction of the total angle of the circle, which is 360 degrees. So as it's done in here, that is the correct way to approach it. And we know that our radius, so this is our area right here, and we're writing it as a fraction of the angle that we're given. So in this case, we're talking about this slice right here. We're finding this area of this slice, and we are subtracting out here this part. Alright, so this is the area of that slice, and then we are subtracting out the actual area of the triangle right here. So area of the slice minus area of the triangle. Okay, so the area of the triangle is pretty straightforward. So when we have an equilateral triangle, we assume a height right here. So this is an angle 90, this is an angle 30 degrees, and it's going to be 1/2 base times height, right? So if we go 1/2 base times height, so the height, the base here is our radius, so times 6, and our height here would basically just be, so height, and sorry, my bad, so sine of 60 degrees is equal to our height divided by our radius. So our height, and the sine of 60 degrees we know is radical 3/2. So sine of 60 degrees times our radius, which is 6. Okay? And then from there, wait, I might be doing something wrong here. Okay, so evaluating this here. So okay. I apologize, 1 second. Okay, yeah, so area of the triangle here. We have 6 coming in for our radius. This side is 6 as well. This side is 6 as well. This side right here, we would find this h right here. Our base is 3, my bad. Our base should be 3 in this case. So we would have sine of, okay, yeah, so cosine 60, that works out. Sine of 60 is equal to h over 6. And in this case, the sine of 60 is root 3 over 2 times 6, so 3 root 3. Okay? So that's the value of our h. So we would have 1/2 3 root 3. So that would be our height times our base. Okay? So evaluating that, we would have 60 degrees over 360 degrees times pi times our radius, which we found to be 6. And then right here we would have a 9/2 root 3. And then we would do 1/6 pi times 36, which will just give us 6 pi in the next line, and then minus 4.5 root 3. Okay, and then we would get 6 pi minus 4.5 root 3. Okay, in that case I'm actually looking at this solution and I'm wondering why we're doing it this way. So obviously that's sine 60 times. So they're finding the area of the sector OPRQ. OPRQ. So that would just be 1/6 of the entire thing. So that would be 1/6 of the entire thing. So that's 6 pi. Subtracted from the area of the triangle OPQ. Finding OPQ here, we have 6 and 6. So just once again going to find this triangle and see if the solution is wrong or not. So taking it from this perspective, we know this is 3, we know this is 6, we know this is h. So sine of 60 is going to equal h over 6. So root 3 over 2 is equal to h over 6. So h is 3 root 3. Finding the area of this triangle here is just 1/2 base times height. So I think this is where we might have went wrong here in this problem. It's that they did not divide by 2 for this term right here. So as you can see here, I believe that this should be 4.5 root 3. So let's just continue on with the problem. And we are going to get the following. Area of the given circle, yes. So this is just the area of the small part, or I apologize. Yeah, this is the area of the small part. So because essentially what we've done is we've calculated this entire region here, subtracted out the triangle here. Okay? I'm just double checking here. Would not want to be wrong. Okay. So then the route that the person takes in this problem is the correct route. So if this is the small part here, right here, and we want to find the area of everything, we take the area of everything and subtract it from the small part. So the area of everything as we know it is pi r squared and subtracted from the small part. small part in this case would be pi r squared minus 6 pi minus 4.5 root 3. Alright, so in this case we can evaluate it to be pi times 6 squared minus 6 pi and then plus 4.5 root 3. And then we would find it to be, this is 36 pi, so we'd get 30 pi plus 4.5 root 3. Okay, and obviously because we're talking about meters here and we're talking about area, we should have meters squared in the answer. So I am just going to look over this one more time because I like to be certain. So times side squared. Okay, yeah, sorry guys. So I only found the area of a single triangle here. So this that I computed here, that is completely my fault here. I only computed the area of a single triangle. So this this 4.5 right here, we should multiply this entire term by 2. So the solution as stated is correct. So I apologize about the work. This should be a 9, and this should be a 9 as well, and this should be a 9. Let me just explain my error here. I only found the this 3 root 3 is the area. If this is the entire triangle, I only found it of 1/2 of it. So I should have multiplied my result by 2. So that's a silly mistake by me. The times 2 should go here. So I hope you could have followed along with all of that mess, but I believe that as it's written here, this explanation, this text-based explanation, is a lot better than the one that I've provided. So great solution. Good job.